started.
Yeah.
Okay. Okay. So I hope everyone, Mahesh and uh, Iftikhar, you were able to install the IDEs. So
Yeah, I have done.
yeah, from now on, I'll be diving deep into the code. So mostly I'll be showing the code, I'll be explaining the code and that kind. So the first class was kind of an introduction, so I didn't go deep into it. So starting now, we'll be going deep into the code. Let me first show the PPT where we were last week, what we have discussed. So yeah, so in last week we have discussed some introduction, the syntax, what how a comment looks like, what are the variables, how you generally differentiate constants from variables, what are the different types of numbers and Boolean data types, complex data type, and then we discussed on assignment, arithmetic, comparison, and logical operators. Identity and membership we didn't discuss at the moment. We'll come back to them. So I've asked you to create an account in Git and install an IDE, preferably VS Code because I am using VS Code. But you are not limited to this IDE. You can use any IDE that you are comfortable with. Um, okay. So
Mm-hmm.
next is on today's will be. Let me just is okay. So today we'll be talking about data types, advanced data types. Data types is kind of a revision of what we did last time, but on the code side, I'll not be talking in air now. Everything is on code. Advanced data types, mostly data structures, the defined basic data structures. Then we'll talk about a topic called flow of code, which will help you understand why some components are needed. Then we'll talk about
Mm-hmm.
algorithms. So this is where I'll spend most of the time here. And then we'll talk
Mm-hmm.
about conditionals and loops, which affect the flow of code. So these two in turn affects flow of code. So we'll see how that happens. Okay.
Okay.
So let's talk about first topic, data types. As I said, I have a Jupyter notebook open. You can use Jupyter notebook. You can use any other code, but Jupyter notebook is simpler because you will be able to type something here. Okay, sorry.
Is it
You'll
in
be able to
VS Code?
Jupyter notebook. Yes, in VS Code, I have a extension inside VS Code to do Jupyter notebook. So that is what I'm using now.
Mm-hmm.
Okay,
So let me check even if I can.
you
So.
should be able to. So you will just have to go to extensions here. Um, Let me give me
Mm-hmm.
1 second. Where is my mouse? Okay. Um. Okay. So you'll click on Jupyter this extension and you will just install it. Once you install it, it'll pull other things as well and it'll give you an option to start your Jupyter notebook. Okay.
But in my side, like it's showing different, like Jupyter kind. It's not showing the one you had open.
Yeah, the style might be different, but see, when you open from Anaconda, you will get. I'm opening Anaconda Navigator now. So let us see how it will be. It will be completely different, but effectively the same. It looks different, but it works same. So any Jupyter Notebook extension, either in VS Code or Jupyter Lab or Jupyter Notebook, will work similarly. Okay.
Mm,
So
like
I
from
guess
after
you will
going
be
to the.
opening from here. Maybe let's say Jupyter Notebook or Jupyter Lab, one of these, for example. So launch this. It will
Okay, I'm launching.
give you a notebook like this, which is in your browser actually. Hello.
It's going like after opening that, after launching that, it's showing me like it's opening a window and saying that showing desktop documents downloads. Mm.
Um, okay, give me 1 second. Why is- Yeah. Okay, so Now let's look at the basic data types of integer, float, and complex. So when I run this and when I say what is the type of A, it would say it as an integer. Okay.
Okay.
Or if I type of B, it will be a float. So integer and float, the major difference is that integers are numbers without decimal points. Floats are more complex, which will have decimal points as well. And they take more space in your RAM actually. And complex is a third
Mm-hmm.
type, which is for complex numbers. So it is generally it is not there in any other language. In Python, it is inbuilt directly.
Mm-hmm.
Okay. So that is on understanding the different types of basic data types. Then you have other types called as booleans, where you have true values or false values. So these could be
Mm-hmm.
represented as 0 or 1 binary values, but they are called as true or false values only. So even you can say one is true, zero is false in most cases, binary representation of true or false. Okay. So if you do this bin of false, okay, where it tries to convert false to binary, it converts it to zero. If you do bin of true, when it converts to binary, it will convert it to one. So that is the intent of true or false. So actually, in memory, it is represented as true or false, sorry, 0 or 1. But for us to see, it would look like it is either true or false. Okay.
Mm-hmm.
So true is always 1, false is always 0. And these are the basics which will help us in all logical operators where you have to compare two things and come up with a case by case of what it should do. Okay. Next, going to the next one, strings. So strings can either start with a double quote and end with a double quote, or strings can start with a single quote and end with a single quote. So both of these are valid. So this is a valid string, is valid, and this is also a valid string, is valid. But if I try to write it in two lines, then it will throw an error. So you can see here, these are the errors that this will throw up. So this actually for you, this extension is not there, so it won't show you here. But after you run it, you will get an error here. Say the same error, whatever you see here. But for
Mm-hmm.
me, I have made it such that it's easier for me to explain, and you can see the errors coming up on the go. So I have uh, put it here. I would not recommend you to start using this extension right now. So because you should be able to identify the errors without someone prompting you every time. So for that reason, I wouldn't recommend that extension right now. Maybe once you have become quite experienced in writing code, then that extension would help you faster in doing debugging faster while you are writing itself. But at this moment when you're learning, don't use that extension. But I will use it so that you will know what are the errors that happens if we do that. Okay.
Mm-hmm.
So if I run this everything is coming up, it's running properly. You get a green check mark here. This indicates that this entire blue box is called as a cell. Each cell. So what is the advantage of Jupyter is you can run this code separately from entire other code in the file. But imagine if you are writing it in a simple language here, for example, let's say Python. If you write a .py file and you write the same thing, you cannot run only a part of the code and then you will say, I'll not run the other part of the code. So when you run this file, everything will be running from top to down. Okay. But
Mm-hmm.
uh, for you to do some testing or for you to understand and see what is the output immediately, Jupyter is helpful in that way. So you can actually go and see what is happening every time you run a particular line. So every cell is a unique block of code that is run and it is appended to the previous memory states. Okay. So basically, uh, you can come back to why Jupyter, what Jupyter is later. Right now, you just need to know that you can run it in smaller chunks. That's it. And it's helpful for you
Mm-hmm.
because you can see each chunk how it works out. Then,
Mm-hmm.
as I said, if you use a string multi-line, if you want to write multi-line, it will throw you an error. But there are ways in which you can make multi-line strings. Okay, so there is a uh, multi-line string input called triple quotations. It could either, again, similar to single quotations, it could either be double quotations or single quotations. And this is a multi-line string. Okay. And here we can go to any number of lines.
Mm-hmm.
Okay. And until you are within these quotations, starting quotations and ending quotations, if you write 1,000 lines, all of them are taken as multi-line strings. Similarly, this is also a multi-line string. Okay. Something here. So this does not throw an error as how this is throwing, because these strings, the input when you start and end, these are telling that it is a multi-line string. Understood? These are something which we
Mm-hmm.
have discussed previously, so I'm going a bit quick. And strings is something which we'll come back to in much detail at some point later. Okay.
Mm-hmm.
Maybe next week after third or fourth class, we'll come back to strings, because strings is like your bread and butter. Most of your processing you'll do on strings most of the time. So we'll come back to that again. Okay.
Okay.
This is basically explaining the data type. We'll come back to strings after some time. Okay. Now, I think this initial data type section is done. These are your basic data types. Now, we'll have to talk about data structures. So, what is the difference between a data structure and a data type? Is that in a data structure, you will not have single data, but you can have multiple data. Okay. So, uh, these are the four defined data types within Python, but there are multitude of data types that actually, if you look at the theoretical data structure course, you will have data types such as queue, stack, hash map, uh, then array, then yeah, set tuples, everything. All of these are actually the theoretical data structures, but these are not implicitly defined in Python. The things that are defined in Python are lists, tuples, sets, and dictionaries. And I have brought in an extra difference between these two, because lists and tuples are mostly alike, sets and dictionaries are mostly alike. But all of them are data structures. When I say data structure, it means it somehow has multitude of pockets where you put your data. Okay.
Mm-hmm.
So when I say list, so list always starts and ends with a square bracket. So in a square bracket, you can put anything. So you can say, for example, I can add a string. Okay, this is a string. Um, I can add a number 5. Let's say I can add a floating point number. I can add a complex number. 5 plus 7j. I can add a boolean. I can add anything else. I can even add a list within a list also. Okay. List can contain anything. So this list is of, what is the size of this list now? Imagine, okay, when I run this, this will run without any error. What is the size of this list? Size of the list or length of the list is basically how many elements it has. It has a string,
Mm-hmm.
it has a number 2, it has a floating point number 3, it has a
Floating,
complex 4, it has
complex,
a boolean 5, it
boolean.
has another list. Okay, 6. So if I try to find the length of the list using a function called len, okay, I'll come back
Yeah.
to some defined functions after some time. I'll keep using them now, but basically I'll come back to them after some time, okay, by the end of today's course.
Mm-hmm.
Okay, so if I run, it says 6 here. So you can see it says the length of the this list is 6. Basically, it says there are 6 elements within this list. You can have lists starting from one element, no element, and up to your maximum RAM, how much it can hold, that much length you can go up to. Okay, you can go millions of length as well. But list, okay, you have understood what is a list now. It is a data structure.
Yes.
It can hold elements That elements could be of any data type. It could be of a data structure itself as well. Okay.
Mm-hmm.
Next is called as tuple. Tuples and lists, the only difference is that it's almost exactly same as lists. Okay. The only difference is that tuples you'll represent it. Okay. The first difference is that you'll represent by round brackets instead of square brackets. Okay. The second difference is that lists are editable, tuples are not editable. Okay. What do I mean by that? So if you are fetching some data, and if you want to not change that data but just use that data somewhere, okay, you will prefer using a tuple rather than a list, because this
Mm-hmm.
takes lesser memory, lesser space compared to a list. Everything almost is similar. The property is called as mutability. Okay, lists are mutable, tuples are immutable.
Immediately.
Okay, I'll okay, so lists basically you can change them after you define them. Okay, so
Mm-hmm.
what I'm writing here, let's say this is like list li is equals to, okay, let's say I'm writing a b c comma 1 comma 2 3 comma let's say 5 comma 6. Okay,
Mm-hmm.
okay, and I'm saying pup tup is equals to, let let me take the same elements, okay, inside a tuple. But as I said, tuple will be represented by uh, round brackets instead of square brackets, so I'm changing those brackets here. Okay, so list, you are
Mm-hmm.
able to read it as here. It has how many elements now?
One, two, three, five in
Five
list.
elements. Tuple, it has five elements. Okay, I
Five.
have defined both of them here. Okay, now if I say what is li here, it says this thing. This is li, which is basically the same thing which we have defined it as. If I say what is stub, it says it is this thing. Basically, it gives exactly what we have defined. But for example, li dot append if I do, and if I say, for example, write Python class. Okay. And now if I run what is an li. Okay. So what it does is it will append at the end of the list, it will append one more whatever we have added here. Since
Mm-hmm.
this is mutable, mutable means it is changeable. You are able to modify it whenever you want. Okay.
Yeah.
Using something called as methods. I'll come back to this. What is methods? What is functions? What are all those? I'll come back to them. I'll explain in detail after some time. So, but append basically appends at the end of the list the new element. If I try to do the same thing for tuple, it will not allow me. It will throw an error. Okay. You can already see an error popping up. So here you can see this is by VS Code says this is coded by yellow. Basically, it says it is uh, able to find this method within its definition. Here it's coding with white because it is unable to find this within the definition. So if I run it, it says tuple has no attribute append, so it is not able to do it. It cannot add it. You are not supposed to change it. Okay.
Mm-hmm.
So tuple and list are almost similar. Uh, Unless you are looking at a very complex data, you can use them interchangeably. Prefer using lists most of the time, unless like if you have 10,000 elements in your list and you are not changing those elements, you are just referring to those elements, like you are pulling the data, but you are not writing the data to it. In that cases, you will go to tuple because it will save a lot of memory for you. Okay.
Mm-hmm.
Okay.
Okay.
So you
Okay.
understood what lists and tuples are?
Yes.
Okay. Now, the next thing is called as sets. Okay. Set. I hope you have your remember your max classes long back, which
Mm-hmm.
basically says what a set is. Uh, this is kind of similar to that. Basically, you if you want to imagine it's kind of a sack of items. Okay.
Mm-hmm.
So imagine you have 10 different types of chocolates in a bag where you are unable to see and pick what you want, but you just put your hand randomly and pick one thing. It'll throw any one of them. It need not be in the same order that you put it in. Okay. Set
Mhm.
is defined by flower brackets. Okay. And for example, I'll use the same elements as in list here. Okay. I'll not change that for now. Let me define sets as this thing. Okay. The only difference is that in sets, it is, as I said, it is a bag of elements. So it
Mhm.
need not always throw out. So actually, if you see here, I have defined it ABC 1, 3, 5, 6. List also I have defined it in the same order. Here, order is mattering. List and tuple, the order matters. So if I define ABC first,
Okay.
every time you read it, it will come ABC first only.
Mhm.
Okay, it will not change that order no matter what, because order is stored within these two data sets, data structures, sorry. In sets, the
Mhm.
order is not stored. All the elements are stored. Okay, order is not stored.
Mhm.
So,
Mhm.
in sets, if you see here, it is pulling the data, but you see ABC, which we initially gave at the start, it is coming at the end here.
Mhm.
Okay, and there is one
Each time
more.
when we run it, each time when we run it, it will come in different. The
Ideally, it
set
should, but
answer.
no, it won't come. If you take a very big set of like 10,000, 15,000 elements, you can see every time you run it, it'll come different. For smaller sets, you will not see that difference actually. So, yeah,
Okay.
it's, yeah. Okay, so set is similar to lists and tuples, but order doesn't matter. Okay. So now
Mhm.
let us assume I'll add another element for all three of them in a list, in a tuple, in a set, which is similar to a previous element. Okay. So here I'm adding a 5, which is similar to the previous 5. Okay. Since when I'm defining this data structure in a list, that will still remain because you are, along with the number 5, you are also saying that it is placed at the location 1, 2, 3, 4, 5, 6. It is placed at, it is the sixth element of my list, you are saying. Okay.
Mhm.
So this 5 is different from the fourth element of the list, even though both of them value are same. Similarly, in
Mhm.
tuple, if you do, it will also, if I run it here, it will also store the position of every element, and it will not, if there are even same elements repeated at different positions, it will retain it. But in a set, when you run, it will not do that because it does not store the position. It does not store the order. If there is an element, 100 times you put that element in a set, it will only store it once.
Okay.
Okay. So that is one major difference of sets versus lists. So uh, it is very useful in many cases. How is it useful? We can come back to it when we are actually doing some coding and we'll see. So um,
Okay.
set, as I said, it is an unordered collection of items. Okay.
Mhm.
Tuple and lists are ordered collection of items. Lists are mutable. Tuples are immutable. I mean, you cannot edit it once you define it. So whatever editing you do, you can do it in for this line. But next time when you refer to it, you are just seeing what is already there. You will never be able to edit it.
Mhm.
Okay. Then the final data type, data structure defined is a dictionary. Okay. This is the most versatile, I would say, the data structure amongst all of them. Okay.
Mhm.
Why am I saying that? Is this also you will define it as an open and close flower brackets, but here instead of here, okay, in list you are defining each position and saying this 5 is present in, okay, in any programming language, the numbering will always start from 0. Okay, you will not count
Mhm.
first
Yeah.
element, second element. You will always count 0th element, first element, second element. So the position of this tree is 0, 1, and 2. This is the position of 3. Okay. Um,
Mhm.
the position of 5 is 0, 1, 2, 3. So for example, if
Great.
I say, get me the element at position 3, position 3 means that it is fourth position. So you'll get
Mm-hmm.
5 because it will count this as 0, this as 1, this as 2, this is 3. So it will bring that element. Okay. Similarly, in tuple, you can get a particular element at a particular position. Okay. For that
Mm-hmm.
position, what is there, it will give you. In set, you are unable to do it because, as I said, you don't have that positions defined. Okay.
Mm-hmm.
Dictionary,
Yeah.
you will have positions defined, but instead of them defining what is the positioning key, the numbers as the key, you will define the key. So you can say class 1. Okay. I have defined introduction to Python. Okay. Class 2, I'm saying data structures. Okay. So this is how you can define this first term. Okay. So in a dictionary, you will have a key value pair. It is a pair of elements you define when you define a dictionary. Okay. The first item is called as a key. The second item is called as a value. Okay.
Mm-hmm.
And you can define in that way
Exactly.
for your entire dictionary. So dictionary is similar to sets. It does not have order also, but you can pull specifically the key based values because you have keys defined. You can pull key based, you can pull. So for example, when I define this dictionary, if I run di of, let's say, class 1, okay, it will give
So
you
is
its
it
value.
using flower brackets or square brackets?
Okay, this bracket, what I'm doing here is called as indexing. Okay, it basically you are telling within the dictionary, show me this value. Okay, so when I say list, show me everything, it will show this. But I want, let's say, fifth element of the list. Okay, so then what I'll say, 4. Then it will give you the fifth element of the list. So this square bracket that you see here are called as indexing. So you are indexing into the fourth element of the list here. You are able to
Okay,
understand.
sir.
So definition is
I'm a bit
different.
confused on this.
Okay, yeah, okay. Okay, let's go to OneNote and let us understand here. Okay, let me go here, open this, and yes. Okay, so this is not how lists are defined actually, but let us
Mhm.
assume. Okay, so
No, just I'm confused about the brackets, sometimes when you're using
yeah,
square bracket
I'll
and then.
tell you. I'll tell you. So lists and tuples are defined like this. Set is
Mhm.
defined like this. Okay, and dictionary is also defined something like this. But okay, so for example, in lists or tuples, for example, every position you are saying this is a value here, this is a value here, this is a value here, this is a value here. Okay, in sets you are saying there is no position, these are the values within the sets.
Mhm.
Okay, in dictionary you are saying again there is no position. I have a key value pair. K1 is ABC. Okay, string of ABC. The K1 itself is also a string. Then
Mhm.
K2 is a string of XYZ. Okay, for example.
Mhm.
So if
Okay.
you want to get, let's say, second element of the list, you will be able to do by just going, okay, this is 0th element, this is first element. So second element means 1. Okay, okay. Before I go there, lists, as I said, we'll define lists by using square brackets. Defining a list is always using square brackets. Defining a tuple is
Mhm.
always using round brackets. Defining a set is
Mhm.
always using flower brackets. Defining a
Okay.
dictionary is also using flower brackets because I'm using key value pair. This will differentiate from the value here. So here it will only have values, that is a set. Here it will have key and value separated by a colon.
Okay.
That is dictionary. Okay. Defining is always square, round, flower brackets. This you are clear in?
Mm.
Okay.
Yeah. Yeah.
Defining part is done. So data side. Now, when you want to go inside a list and get an value, or go inside something and get some values, okay,
Mm-hmm.
okay, go inside any data structure and get a value. Okay, so I'll explain for dictionary. Okay, for dictionary,
Mm-hmm.
let's say the dictionary name, the variable name is di, which I have defined in my Jupyter notebook. So I have to get the K2 keys related value from this dictionary. So I will use indexing. So without any space here, I'll directly open a square bracket and say K2. Okay.
Mm-hmm.
So what does this mean is inside the dictionary, find the key called K2 and give its value as output to me. So the output that you will get from here is XYZ.
Okay.
Okay. So here this brackets are called square brackets and these are called indexing. These are different from defining. In defining, you are doing something that is done already. Okay.
Mm-hmm.
Here your variable name. So here you are giving variable name, then you are giving a bracket, and then you are giving position or key.
Mm-hmm.
Okay. This kind of definition is basically you're indexing inside a data structure and picking one value. So, for example, like modern day bags, you will have a place to keep your place to keep your pencil. You can open directly, pull your pen out, and then you can start working. In older day bags, you will not have all that. Everything is dumped into. You'll open and you'll pull all of them and see, and then you'll do that, right? So
Mm-hmm.
this brackets here, so let me just for the sake of your understanding, let me put it in a different color. Okay. These brackets here are different from whatever the brackets you see here. These are not the same as these brackets. These brackets
Okay.
are used to define data structures. These are defined that for dictionaries, you will always use flower brackets. For sets, you will always use flower brackets. For tuple, you will always use round brackets. For list, you will always use square brackets. For
Only this is for the indexing.
for
Okay.
getting the values, for pulling the values, for indexing, you will always use square brackets. Why? Because
Okay.
when you use, if you use for example round brackets here, this meaning will
Mhm.
change. Di, this thing is meant to be either a function or a method. Okay. For example, earlier I wrote length of something. Okay. Here you see, here I'm using square round brackets. So round brackets in Python definition are used for functions. So to differentiate this from this, here you have some name and some brackets here.
I
This is
think
similar to name and brackets here.
your
Correct?
marking is it's not showing here when you're marking it. Mm.
What
It
is
got
not showing?
stuck.
Or is it? Let me stop and restart my sharing. You're able to see now?
Yeah, now I can see.
Okay. So this definition I'll come back to in some time. Okay. I didn't want to confuse
Mm-hmm.
you and bring all this into it. So but we'll use round brackets in a different scenario. That is where we are not using them here.
Mm-hmm.
Okay. So indexing
Okay.
brackets are different from whatever you are seeing. Okay. Now let's go
Mm-hmm.
back to VS Code again. Okay. So here when I'm giving a name, after that I'm giving a bracket. This
Mm-hmm.
is different from the bracket here. Okay. Definition brackets are different. And these are indexing brackets. Indexing you'll always use square brackets. Clear?
Okay. Okay.
Okay.
So we
So
don't need to leave the space between that, right? Like
no,
as you
no
said.
space. It is, you are saying inside this variable, go to second position and give the value for it. Inside this, go to
Mm-hmm.
second position and give the value for it. Set, you can try this. It will say it's not subscriptable. Subscription
Mm-hmm.
basically means you are going inside it and saying set. As I said, you cannot have order, so you cannot
Yeah.
subscript it. But dictionary, though it is similar to set in terms of like you will have a bag of things where it is not ordered similar to lists or tuples. Because you're defining key value pairs, you can pull
Mm-hmm.
based on keys.
Key
Okay.
values. Okay.
So keys are the ones which we'll use to pull the values.
Mm.
Okay. So because you're using keys to pull values, your keys should be unique in dictionary. Okay. You cannot have keys repeating. Values can repeat, but keys cannot repeat. Okay, so
Okay.
for example, if I say, let's say again class 2 again here, it is dictionary entries must contain key value pairs. Okay, let's say, let me put the value pair as well. Okay, something here. If I run this, it's taking, but it will not, it is an issue. So it is, why is this taking? It should throw an error. Okay, it's throwing away this value and overwriting it with this value.
Mm-hmm.
Okay, so if you have to have, your key should always be unique.
Okay.
Okay,
So
so now
if it is double key, so like if it use the same key, saying
mhm,
then will it like I think it will take the latest one or how it is will show
I
throwing
think
error.
it will take the latest one. So what actually happens in the back end is there's something called as hash string. Okay, we'll not go into that depth now, but basically what happens is your keys are hashed, and that hash is
Mhm.
used to represent the key inside your data structure. So when you hash this key and the value is tagged to it, when you do a hashing again of that key and tag the different value, what happens is you will basically override this with this one. Yeah, pointer to this will overwrite with this one. Let's not go into that detail right now. Let's basically remember your keys have to be different if you want to retain all your data.
Mhm.
Okay. So
Okay.
I hope you are understanding what data structures are. Uh, any confusion in definition of these data structures?
No, that's it. I got it now.
The power of data structures is, for example, I can define, okay, like here, and I can give it a value of a list. Okay. So for example, inside a dictionary, class 4, if I see, it takes the value of this list and puts it inside this key. Okay. So
Okay. So
inside
you're
a
putting
dictionary,
text
you can
inside.
define a key as well. You can define a list as well. Inside a set, you can define a list as well. So any data structure you can define within other data structure. So for example, here, if I want, I can create a new dictionary and put it inside this as well. Okay. ABC value is PQR, let's say. This is also valid. So you're able to see you are putting nesting a structure inside another structure, and that gives you very uh, powerful use cases. Okay, so it's not just a unique values of the basic data types that you can nest inside. You can nest anything inside a data structure.
What about in tuples? You can do in that as
Anything,
well.
anywhere. It's not an error if you do it anywhere. Every place you
Mm-hmm.
can do. I can put it inside this also. Okay. Only thing is that I cannot use a list as a key. Okay, that's it. So if I do this, it will throw an error. Okay, if I do this, it will throw an error. Okay, it says unhashable type because list is not hashable. Because list is
Okay.
mutable, it is not hashable actually. So you cannot put things that change in future as a key basically. Okay, so lists can change in future because they are mutable. You cannot put them here. So here you can put a tuple instead if you want. As key you can put a tuple. There are very random, very like unique cases where you'll use tuples or something as a key. You'll rarely use it, but unhashable type. Why is it unhashable type? Oh, sorry. Okay, yeah. Inside set also you cannot put a dictionary. So again, here it's throwing an error saying you cannot do that. So tuples you can do. You can
Why
put
did
as
you put
keys.
the comma between this?
So Python, it's a dynamically typed language. So what happens is if I say this, okay, it will take it as a normal string only.
Mm-hmm.
Okay, to indicate that this is a string of element of one size, I put a comma here. Okay, because why it is this? For example, when you are doing math, you will do 25 plus t. So here you are using brackets. These brackets are meant to do this operation here, correct?
Mm-hmm.
So
Yeah.
similarly, when you write a string here, for example, this assumes that this operation is being done inside these brackets. But you want
Mm-hmm.
it to be a tuple, not a bracket just for doing an operation. So for it to understand that, I'm putting a comma here to say it will have some other elements next to it. So then it will take it as a tuple. So for example, I'll
Okay.
just,
So anytime, whenever you want to use that, you need to put a comma.
if it is only a single element list,
Mm-hmm.
okay. So here, type of this, if you read, it is a tuple. Okay. If I remove this comma, it will ignore the brackets and it will say this is a string.
Okay.
Okay. But if I do like two elements instead of ABC and I'll do ABC and PQR, then now it knows that these brackets are not intended for just uh, uh, clarity sake. So it is meant to be used as tuple. It will directly take it as tuple. So Python is intelligent enough to know these brackets are they used for your reading purpose or they are used for the purpose of defining a tuple.
Mm-hmm.
So only case where it is not able to understand is when it there's a single element inside a tuple. So in
Okay.
that case, you have to give a comma here. Okay.
Mm-hmm.
So I hope you understood what the data structures and you have a good understanding of how to use it.
Yeah.
Okay.
For the
I guess
dictionary, you said there's a key and the variable, right? Key to the
key value. It's called as
key
key
value.
value. Key comma value. It's always key value pair. It's a pair. You should, in a dictionary, you should define a pair of things. You cannot define one thing because that will become a set.
Mm-hmm.
Okay. Generally, people initially, when you are learning, at least for the first few homeworks, you don't need to consider these two data types. You can only list and dictionary is what you can use directly. Then you can slowly see the importance of these data types coming up after that. Okay. For at least like
Mm-hmm.
first 10 to 15 classes also you don't need to unless you are doing very advanced Python. I mean these functions that these can be done already in lists and dictionary. You don't need to go to these two unless there's a very specific use case. So initially I would suggest at least until you come up with you understand the use case of lists and dictionary, use only these two things. Don't bother going to the other two, tuples and set.
Kappa and sets, you mean?
Yes, I mean, you can use them. I'm not saying it's wrong in using them. They are intended for certain use cases. So, which can be offsetted by using lists and dictionary most of the time. And since once you get your hands on dictionaries and lists as a primary data structures, then you can go to these two kind of special cases of those two. Okay.
Mm-hmm.
So prefer using actually when I was learning Python, I didn't know there was a type called set until like 6 months after. No one told me that there was a type called set, or I don't
Mm-hmm.
remember someone telling me because I didn't get the need of using it until I went in 6 months into the course actually for me. Course in the sense
Mm-hmm.
my self learning. Okay.
Mm-hmm.
So yeah, these two, don't complicate yourself with these two for now. Use only the first list and the last dictionary. That should give you enough playroom to understand data structures and get your hands-on experience with data structures. Once you have that hands-on, you can then go to the other data structures. And as I said, there are other types of data structures like queue, uh, then you have stack, then you have um, hash map. Hash map is kind of exactly like dictionary. Then you have array. Array is almost like list, but it is a more these two are kind of more restricted versions of dictionaries and lists. Okay.
Mm-hmm.
Then you have linked list, double linked list, and other kind of things, which yeah, those are like crazy things. I mean, those are the basic data structures, but Python directly doesn't have them defined internally. So they kind of define these four, which can implement the other things as well.
Mm-hmm.
Okay. So I hope you are aware of now what data structures are. We will again come back
Mm-hmm.
to data structures most likely before or after strings. Okay. So because in data structures, how to add an element at the start, add an element at the end, how to pick an element from the middle, how to remove an element, how to, there are a lot of things we have to discuss. We'll come back to them. And those are
Mm-hmm.
similar to what strings also will do. So those two maybe in a single class or the two classes next to each other. So we'll come back to data structures, especially the list, indexing, slicing, and all those things. We'll come back to them. Okay.
Mm-hmm.
So this is your basic understanding of dictionaries, lists, tuples, and sets. For more advanced understanding, we'll come back to them again.
Okay.
Okay. Now we'll talk about
Mm.
flow of code. There could be a chance that the Teams call will get disconnected. So I'll send you one more link. You can join on that once it
Mm-hmm.
gets disconnected. Okay.
Okay.
Okay. Flow of code. Python will always read your file top to bottom. Okay. Then from left to right. Okay.
Mm-hmm.
Unless you are doing an assignment, obviously. It still reads left to right. Assignment basically it does the right hand side first and then it will do the left hand side. But basically, if you see the code, it reads from left to right always. Okay. So, for example,
Mm-hmm.
if I say 2 plus, if I say 2 plus 3 plus 5, it should actually do 2 plus 3, then 3 plus 5 plus 5 is what it will do. Okay. But look, I cannot talk in terms of this one. So, okay, remember this thing. It always reads top to bottom, left to right. So, in a file, first it will define A is equals to 5. Second, it will define B is equals to 5.0. Third, it will define C is equals to 5.5 plus 6j. Okay. This is the default way in which Python will go. Okay. So, for example,
Mm-hmm.
if I say A is equals to 5, okay, then I'll say A is equals to ABC. Then I'll say A is equals to 5.0. And if I want to read the value of A, what do you think the value of A would be?
5.0.
Yes. So you understood, right? Flow of code is always top to bottom. Left to right, I am
Mm-hmm.
unable to show it practically, but just remember it is always left to right. Okay. Um, but I hope you remember when I said previously, assignment, what it does is it will do everything on
Piles
right
of
hand
A.
side. Sorry. Okay,
Flow
we
of
are done
code.
with data
Mm.
types. We are done with advanced data types. We are done with flow of code. Not completely done. So I'll explain now on note one note some things. So um, okay. So as I said, we'll always in a Python book, if you see in a Python code, not Jupyter, in a Python code, it'll always all the lines. It'll go from top to down. Okay. But after running some line here, if I want to run some line here, okay.
Mm-hmm.
Are you able to see my screen? After this
Yes.
line, if I want to go back to this line, Or
Mm-hmm.
after running this line, let's say, then there are few lines. I don't want to run them, but I want to run these lines after that. Okay. Skip
Mm-hmm.
and go here. And I want to do something like run this in a loop multiple times. Okay.
Mm-hmm.
So
Mm-hmm.
by default, Python will go top to down, but there are ways you can make it do all these things as well. Okay.
Mm-hmm.
So some of those ways are using some inbuilt structure, not structures, not even functions, uh, uh, loops and using something called as loops and conditionals. Okay.
Mm-hmm.
Last time I told there are around 33 reserved keywords. Of those 33 reserved keywords are few words called while, if, for, else, elif.
Else if
Yeah. These are used to change the way the code is run. So you can use while and for to do something called as loops. So you can run more than the same code more than once. You can do if and else and elif to jump from one place to another, jump places. Okay. Or
okay.
it is kind of like a conditional. It works on a condition.
Mm-hmm.
Okay.
While and for.
Okay. So keep this in mind, and I'll keep referring to flow of code indirectly whenever I'm talking about the next type of elements of Python. Okay, like while loop,
Mm-hmm.
for loop, if loop, whatever it is. Okay.
Mm-hmm.
Um. Okay. Let me just now come back to what is it I want to talk about? Algorithms. So
Mm-hmm.
any function or any task. Okay, from now on I want you take a homework to come up any task that you do, write an algorithm for it. Okay, okay. Algorithm is writing it step by step and defining it on a chart is called as a flow chart. Okay,
Mm-hmm.
so for example, if you want to make tea, okay, step one would be to take vessel, okay,
Mm-hmm.
pour water, okay. Third one, boil water. Fourth, add tea leaves. Okay. Fifth, um, what else? Add milk. Okay. Then you will strain it into glass. Okay. Then drink. Okay. These are the 7 steps.
Mm-hmm.
Okay. So if you tell me this, I'll be able to do this, correct?
Yeah.
But imagine you have a young 1.5 year old kid. If you tell him this, will he be able to do exactly what you want him to do?
Mm-hmm. No.
No, right? What will happen is he might not be able to do because my instructions are kind of vague. What do I mean when they are vague? Is when I said take vessel here, for example, you see take vessel I have put here, right?
Yeah.
Um, I'm what do you do after you take vessel? You will make it sit upright. Okay.
Mm.
So imagine this is a vessel. You will take a vessel and you cannot put like this and then pour water, right? So you have
Yeah.
to put it in this way. So you have to orient properly. Then you have to if check if there is any dust in it. Okay. Then you have to clean it if there is a dust in it. Then
Mhm.
you have to, uh, if you don't want that water to retain, you will have to dry it. Then you can pour water in it, for example. Okay.
Mhm.
So these all steps I haven't told you in my algorithm, but you knew of them because you have you as a person you will have common sense.
Mhm.
Okay. But computers will not have common sense. Okay.
Mhm.
They will exactly follow your instructions line by line, top to bottom, left to right. That's it. Okay. So
Mhm.
for you to define computer to do something. So what you are doing in programming? Programming basically is you are making programming means you are making computer do some tasks for you. Computer
Mhm.
do tasks for you. Okay. So
Mhm.
basically you are like you are teaching a kid, you are teaching your computer to do some tasks for you. In what cases you
Mhm.
will ask it to do tasks? So if it is repetitive tasks which you don't want to do, or you don't like to do the task, or tasks which do not need much thought process.
Mhm.
Okay, only those kinds of tasks you want computer to do. And there's one more thing called, let's say you have to do this task only once. Okay, in your entire life you have to do this task only once. Do you really need to have a computer to do that task for you?
Mhm.
Or let's say you'll do it only once and it will take you 5 minutes to do it manually. Okay.
Mhm.
Do you need a computer for you to, do you need a program to write the program in 60 minutes or something and to do that 5 minutes worth of task? So programs are intended to ease your life. So if programming takes more time or effort than what your actual task is, you will not try using programming to do that. You will do it directly.
Mhm.
Okay. So that is your the need of any programming. But the
Mhm.
thing is, computer is like a child with zero common sense.
Mhm.
Okay. So imagine you are explaining something to a child with zero common sense. They do not have any kind of common sense. How will you explain something to them? So that is how you have to write a program.
Mhm.
Okay. So you have to assume, not assume, you have to know that if there is some chance of thing going wrong, okay, because there is zero common sense, your child, if you take a small kid, okay, he will, if you tell him these 7 steps of doing making tea, he will either uh, uh, pour everything on himself. He'll either pour water such that it will overflow the vessel, it will not completely inside the vessel, so you have to tell pour water, how much water, until it fills some capacity. Okay.
Mhm.
Or let's say when
Mhm.
you say boil water, how much time you have to boil water. So you have to define things in much more detail. Okay. In much more refined way.
Mhm.
Okay.
Mhm.
So for you to do that and write it such that you will program it. So basically you're telling computer. So instead of, so for example, you and I are speaking. Let's say I'm explaining things to you, or you're explaining things to your kid. You will explain it in your native tongue, your mother tongue, whatever be the language. Right now, we are communicating in English. For you to communicate to a computer, there are multiple languages. One of those is Python, and Python has a set of grammar, which is what we were learning until now. Okay, what is a list? You will have brackets, square brackets for a list, or you will
Mhm.
have round brackets for a set. Those are the grammar of Python. Okay, so for computer to understand that this is a list, it has to know that it will be within square brackets only. For it to know that it is a tuple, it will always be within round brackets only. It will be able to understand once you talk in its grammar. Okay,
Mhm.
so now, so maybe that will help you understand some logic. Okay, so now take any task. Okay, it need not be a task of something working on a computer. take any task, it will always have a start and stop. Okay.
Mm-hmm.
So always in a flow chart, you will define start and stop by
Oval. Yeah.
ovals. Okay.
Certainly.
Then you will have arrows pointing to the flow of what is happening. Okay. If you want to define something like actually T, or sorry, not T, what was it? Take vessel.
Mm-hmm.
Okay. Within this, you can have multiple steps. Again, it could have multiple things. It could have multiple things. Okay. So on a higher level, I'm drawing here right now. Okay.
Mm-hmm.
Then you will say pour water
Mm-hmm.
or something. Let's take. And let's say you have a choice here, for example. Then you will use diamond to represent choices. Choice. Generally, choice are of two types.
Yes.
You'll either have yes or no. You can have multiple choice, but generally it is yes or no choices. If yes, do this. If no, do this. Okay.
Mm-hmm.
Or if yes, do this and go back to here. So you'll go as a loop. You'll run as a loop until you come to no,
Mm-hmm.
and then you'll come out of the loop here. Okay. So
Okay.
I want you to start thinking in terms of flowcharts for everything.
Mm-hmm.
Okay. So, okay, there's something called as abstraction. So, what is abstraction is your entire programming language is an abstraction. What do I mean by that? So, computer understands zeros and ones. It does not understand anything else. Okay. So, someone wrote a something called as assembly code, assembly language code to make them understand the zeros and ones, and the higher level language of it is basically we'll write it in, okay, I'll not go to that level right now. Okay, it's it'll confuse you further, so we'll not touch that right now. So what I would say is abstraction basically is like you take this thing and put a layer on top of it, like you'll put a blanket on top of it and say this is the thing that I'm dealing with, this internal thing I'm not touching right now. Okay.
Mm-hmm.
So for example, what I mean by that, so when I said take vessel, okay, this is intended to be an abstraction on top of take vessel of dimensions, dia something, and okay, since you're a mechanical guy, you will know this, all this numbers of depth, something. Okay,
Mm-hmm.
then you know this, right? Symbols.
Yeah.
Yeah.
That.
Okay, so it has to be hollowed on one side. I mean, it has to vessel means it is like a cylinder. Okay, cylinder which has a capacity to hold something. Then it has you will fill not fill water. So you will clean the vessel. Okay, next let's say clean the vessel with uh, neat water, whatever it is, it's drinking water or some water where you can use it. Then dry the
Mhm.
vessel. So instead of saying these three steps every time, I'm saying take vessel. So this take
Okay.
vessel is an abstraction on top of this.
Okay.
Okay, so you understood, right? Instead of this three, I'm
Yeah.
saying this thing. This is an abstraction. So if you see actually your entire programming language, everything are abstractions over top, abstraction on top of abstraction on top of abstraction on top of abstraction coming up to certain level. Okay.
Mm-hmm.
I I hope you remember I said programming Python itself is written in C. Okay. So C is called something called as a low level programming language.
Mm-hmm.
Okay. And Python is written in C. Python itself is defined in C. So Python is kind of an abstraction on top of C. So it will do whatever C is asking you to do, but it will be an easier way to write C code, kind of.
Mm-hmm.
Okay, you are not writing C code actually, but you can understand, right? Over time, this level you'll not even see. For
Mm-hmm.
example, maybe I'll talk in terms of something that you will understand. Okay. Um, you did engineering drawing, I guess, long back in your
Mm-hmm.
first year. Okay. In your first
Yeah.
year, when you say this is a line, this is this thing, then you will have a cycloid, you have an epicycloid, and all that things. Okay.
Mm-hmm.
By the time you came to second year or third year, you will talk about gears. Gears are actually your epicycloidal tooth-based circular cylinder. So you have a cylinder, you have a epicycloid, you have a flat surface, you have a depth to it. Correct.
Mm-hmm.
So
Yeah.
you can say gear is kind of an abstraction on top of all of these, all the geometry.
Mm-hmm.
Okay.
Okay.
So I hope you are able to understand what I mean when I say abstraction.
Yeah.
Okay. So it's a higher level definition of something. So tomorrow, for example, you make a program. Okay. So
Mm-hmm.
okay, when in AutoCAD you draw a circle, front view, then you will draw a cylinder, top view, and you will say this is a cylinder. Okay,
Mm-hmm.
but in CATIA or in NX or in other programs, you will directly select a cylinder. This is an abstraction where you are able to see this directly because of some code that is written to 3D visualize it, but you are defining this directly. This in turn is defining your height here, this length here, this dia here, or this depth
Mm-hmm.
here and this dia here. Basically, cylinder means it's an abstraction of dia and depth. So you can talk anything
Mm-hmm.
in terms of abstraction if you want to. Okay.
Yeah.
Why am I focusing on this so much is because if you see your programming is kind of you're trying to abstract as much out as possible. Okay.
Okay.
So now from now on, I want you to anything that you do, eating, sitting, drinking, watching TV, watching anything, thinking about us how to solve a problem, always try to make a flowchart for it. Okay.
Mm-hmm.
So your thought processes should be in terms of flowcharts. Where will I start? What are the steps I'll take? How will I end? So from your office to your home, how will you go? Write a flowchart for it. Okay, try putting it on paper at least for few days. Okay, until you get a hang of it, you just have to close your eyes and you can draw a flowchart in your brain. So that is the level you should be at. Okay, to draw flowcharts.
Mm-hmm.
If you are able to do that, programming is far easier for you. And now, especially nowadays, once you have ChatGPT and other tools, if you know how to make a flowchart for anything, you are able to write code for anything. Okay.
Mm-hmm. Mm-hmm.
Okay. So, and in flowchart, initially,
In flowchart also there is one more thing, right? Input and output something
yeah,
by
that is there. I don't want, I don't, I mean, there are a lot of things. You have this parallelograms and other things. For me, I don't care as much of those things. I am looking at you to start thinking and you to
the
do
steps.
some
Okay.
actions. This could be your action, computer action, or anything. Okay, that is where I didn't define your input, output, and all those things. Okay, those are technical flowcharts. What you're talking. This flowchart is
Mm-hmm.
for you to write a program how you have to think, start thinking. This is that flowchart. So kind of you're using things of technical nature, but I'm leaving out. I'm abstracting out all the things input, output, or everything. I'm assuming to be a rectangle. Okay.
Okay.
I don't want rectangle parallelogram and then something else and confuse you
Mhm.
completely. Okay, so
Yeah.
I'm abstracting
Okay.
that out right now. Okay,
Mm-hmm.
here if you want,
Okay.
you can make it much more detailed. So input is this. So I'll put a parallelogram and do that, and then I'll put after that I'll put a square and do that, and then you can do multiple things. I'll not do that now. Okay,
Mm-hmm.
especially the start and also right now just for your explanation I am using, but I don't use them also when I am thinking of
Mm-hmm.
a solution. So any problem that you take, if you want to open a video in program and then take images out of it, how do you do it as a program? How do you write a program for it? Or if you want to record audio in a program using Python without using like tools like anything, how do you do it? How do you write a program for it? Where do you start? All of that you write a flow chart for all of it. This is what I'll do first. This is what I'll do next. This is what I'll do. Here, actually, I can have two choices. You don't even need this to be a rectangle. Just for sake of convenience, I'm drawing a rhombus here. Okay, two choices,
Mhm.
either this or this. Then I'll do this, then I'll do this, then I'll do this, then I'll do this, for example. Or I'll do this and then I'll do this. This might come like this and this like this, like this. So this is how I'll think. Generally, when I am writing any program, I
Mhm.
I am able to visualize that program at this level. Initially, I'll be abstracted outside, like abstracted level. So I'll have very vague level details I'll be putting in. Then this one,
Mhm.
how do I do this? Then inside that, again, it might have a flowchart. I have to do this, I have to do this, I have to do this, I have to do this. Okay.
Mhm.
This, how do I do? This might again have another flowchart inside this. So it depends on how you write this flowchart in your brain. Okay.
Mhm. Mhm.
This is for your thinking only, whatever I'm talking. Finally, for each of these lines, what is the code that I can write in Python? What is the code in Python? If you are able to abstract to that level, you will easily be able to build whatever module you want. You can build uh, anything in Python with this level if you are able to think in this process. So that is the biggest issue that I have found. I've trained so many people in my office as well, in outside as well. Okay, the major thing, everyone will learn Python happily. Everyone will learn all the grammar, but they'll never learn how to use it properly, how to implement it properly, how to attack a problem using this implementation.
Mhm.
Okay, so that is where I'm trying to ask you from now on, try thinking of anything and everything as a flowchart of actions. Okay, those
Mhm.
actions could be either a choice-based action, either a what do you call some without any choice kind of action or anything. Think of it as a list of actions, as a sequence of actions. Okay, as a flow chart.
Mhm.
Okay, if you are able to do that, and if you are able to divide your problem, so basically what happens is, okay, you will have a problem. Okay, so for example, let me take an example and explain this. Okay, let me this is something on top of in air I am talking. Okay, so you this need not be 100% accurate, but let me try zooming in here. Why is it going left? I shouldn't go there. Let me draw something here. Okay, let's draw here. So let us, okay, let me, I'm spending some time here so that my intention is that you will be able to think of everyday things as problem solving. Okay, as algorithms,
Mhm.
as flowcharts. Once you are able to do this, everything else is easy. Okay,
Mhm.
okay, your thought process has to change to in a way that you are able to do this. Okay, so that is where I'm trying to spend some time here. Okay, let's take any example. So what are you interested in? Which game are you interested in?
Mostly cricket.
Okay, let's take cricket. Okay, imagine you have to write a program to play cricket. Okay,
Mhm.
so how will you write a program to play cricket?
A start.
Okay, so cricket, if you abstract, cricket is an abstraction of three things actually. So batting, bowling, fielding. Okay,
Mhm. Mhm.
okay, batting is an abstraction of what? You will
Bad.
you will stand at a place. Okay, you have 10 players or 11 players. Okay, both
Mhm.
standing on either side of a field, and you can take runs, make a run. Okay, run could either be one, two, three, four, five, six, so on and so forth. And okay,
Mhm.
Bowling is what? You'll throw a ball, that's all.
Mm.
Okay, and it is you will have overs.
Mm.
Fielding is what? You will stop the ball to go to boundary and send it to back to keeper or bowler.
Mm.
Okay, these are your requirements if you have to code a cricket application. Okay, so how do
Mm.
you do that? First, what will happen? Okay, now let's take flowchart. So here some abstractions we have defined. Okay, we have understood what is it at a deeper level. Now let's draw sequence of things. Okay, first what will happen? First toss will happen. Okay,
Mm.
first, okay, before toss also we'll say two teams will be chosen, team A, team B. Okay, team
Mm.
A will choose 11 players, team B will choose 11 players. Okay,
Mm.
that's all. And then let's say next thing will happen is toss will happen.
Toss.
Okay, toss is a conditional. So if heads, team A choice. Okay, if tails, team B choice. Okay, here you have like he can choose batting,
Batting or ball.
he can choose bowling. Okay, similarly
Mm.
here also it can choose batting or here he can choose bowling.
Mm.
Okay, next, what is it? When he chooses batting, he can choose of the 11 players, he can choose two players,
Two players.
two of 11, and send them to bat. Okay,
Mm.
bowling, he can choose one of 11 players, one of
To
11
ball.
to bowl,
Others fielding.
one of 11 to keep. Okay, then remaining 9 players to other fielding.
Mm.
Okay, then so each of the two players, what will they be doing? So player batter. Okay, what will he be doing? He'll stay in crease. Okay, look to hit in gaps. Correct.
Yeah.
Bowling, what will he do? He'll try to hit wickets.
Hot wickets.
Okay. What will keeper do? He'll support bowler
For
to
stump.
come or stop the ball from going if it comes near him.
Mm.
Okay. So this level of detail is okay, or we'll go further detail. Okay. This is
Yes,
like
well.
you are trying to understand the functioning of entire thing. So you are trying to go deeper. You are trying to remove as many abstractions as possible. Okay. Now let's say
Mm-hmm.
you are done to this level, for example, and you are done. Now I'll use a different color to just to indicate how I will code everything. Okay.
Mm-hmm.
So here the choice of batting and bowling is same for both of them.
Mm-hmm.
Correct. So I don't need to
Yeah.
write choice two times. So I can write choose once, I can use it two times. Correct.
Mm-hmm.
It could be team A choosing or team B choosing.
Mm-hmm.
But choose will be the same thing. Any team will choose either batting or bowling. Correct.
Mm-hmm. But
Okay.
both will
Then
do the same
uh,
thing.
again here choosing 11 players for team A or team B is same again. So select
Mm-hmm.
11 players. Okay. This is again one level of abstraction. Okay.
Mm-hmm.
Toss is one abstraction. Okay. And batsmen, any two or all 11 players, when they are batting, he will always try to do something, hit as many runs as possible. Many runs, uh, risk taking to risk shots or not, he'll choose. Okay,
Mm-hmm.
batting. Similarly, bowling. What will he try to do on wicket, or actually he'll try to even catch and other things as well. So he'll try to bowl
Mm-hmm.
such a way that the the batsman will give you catches. So the way he'll hit will give you catches. correct?
Mm-hmm. Yeah.
So, irrespective of the batting is from team A or team B, he'll do the same thing. Irrespective of the bowling is from team A or team B, he'll do the same thing. And fielding
Mm-hmm.
also you can write similarly if you want. Okay, fielding. Also similarly you can write something. Okay,
Mm-hmm.
now these are my abstractions in programming. So in red, whatever you are seeing are programming level abstractions. So I'll write code, okay, saying whenever someone wants to choose, there are two options available, head and task. Randomly select one of them. Okay, randomly select. Okay. So for example, if I have to write code for this thing, it's choosing task. Okay, I'll say
Mm-hmm.
task. Inside this, what will happen is I have two choices. Okay, I'm putting it in a list here, heads or tails. Okay,
Mm-hmm.
and next step of this is random choose one. This is what a task will happen, right? It will randomly choose one. So, and give it back, give what is output, give it back. So when I do a task, what will happen is it will do this and it will give back the value. So if I have to now, let's say talk in terms of code, same thing I'll just write very fastly. Okay, you don't need to understand all of those things, but right now I'll write import random.
On the
Okay,
meeting, yeah. Yeah.
uh,
Mm.
task. Okay, um, choices
So you
is
said
equals to.
define that you used.
I'll come to those things. You don't.
Mm.
Okay, it's our tails. Okay, return random dot choice choices. Okay, so this is how in code I have written whatever I have written in OneNote as as the thing here. Okay, you're able to see
Mhm.
this. So
Yeah.
in code I have written the same thing. So now let's say I'm running. So let's say for example, task I am running it now. Okay, it says heads. If I run it again, it says tails. If I run it again, it says heads this time. If I run it again, again heads, this time tails. So what it is doing is whatever I have written here, it is doing that
Mm-hmm.
in code. So to for Python to understand it, I have written it in a way that it will understand. But basically, I have written this box, this abstraction.
Mm-hmm.
Okay. Then I can write this box, I can write this box. I've shown you an example of one which has very less lines. You can certainly write all of these boxes. Okay. Nothing is
Mm-hmm.
impossible if you really think about it. Only thing is that you might have to divide this further into smaller set of boxes. If you
Mm-hmm.
think you are unable to write this directly, that means that there is some other level you have to go deeper before you write it. So again, you can
Mm-hmm.
write for batting like how I've written for cricket and then you come up with the big requirement that will help you come up with sub-level boxes.
Mm-hmm.
Okay, until you are able to write each box as a code or a set of lines or something like that, you can go to that depth on any action. Okay,
Okay.
this entire thing I have told you for you to understand that nothing is impossible if you want to write, and everything you can write. Only thing is that if you are unable to write it right now, that means that you are thinking at a very high level. You have to go deeper into it, most likely. Or you are thinking wrong also. But let's assume you're most of the time, 90% of the time, people will not be thinking wrong. They'll be thinking, talking at high level. So whenever I said you can program batting, you might be thinking, "Arey, he's saying you are able to program batting, but it's kind of complicated. Pass is easier than batting, right?" But if you
Mm-hmm.
sit down, divide it further, you will be able to do it in further smaller way. Okay.
Mm-hmm.
So I wanted to tell that because if you are able to do this, okay,
Mm-hmm.
Python, C, Java, whatever language in future you want to learn, you can learn it very easily because all of these are basically grammar. Grammar, you as you keep using it, you will learn it. You just have to use it. But if you don't know
Yes.
how to do this, all of these will become your headache.
Mm-hmm.
Okay, so it is like you are thinking, do I write on paper or do I write on pen or using sketch or whatever it is? That will become your bigger problem, but not what to write. So all of
Mm-hmm.
those, why it is, what is the grammar, and all that we can learn certainly, but your important focus should be on problem solving. Okay, for that, the most important thing you need to do is practice. Okay, and
Mm-hmm.
think in terms of flowcharts.
Flow
Okay, start
charts.
thinking in that method. So
Okay.
now let's come back to programming. Okay, now conditionals. So what conditionals do is it helps you divert the code. So earlier I told you, okay, let's go back to one not once. Earlier I told you we will write from top to bottom. Okay,
Mm-hmm.
okay. The
Mm-hmm.
way in Python, you can use if and else block. It's called as a block because what you'll do is if, and then within it you'll have certain number of lines. It could be one line, it could be 100 lines, it could be 1,000 lines, whatever it is. Okay. Then
Mm-hmm.
this is, alone is enough. You need not write anything else. Okay. Or you
Mm-hmm.
can write if else and then this. Or you can write elif also. Okay, but this has to come before else anyways. So let me
Mm-hmm.
just remove this thing. Right, not removing. Fine. Okay, so okay. Now let's go back to code. I'm sorry, I'm wasting time here. Okay, so
Mm-hmm.
A is equals to 5. Okay, B is equals to 6. If something A plus B. Okay, L if something else A plus C. Okay, for example. Okay, C is equals to 8. Okay, else B plus C, for example. What this will do is, for now, I'll just turn this to markdown so that it will not throw errors. Okay. What you are saying is A is this value, B is this value, C is this value. If
Mm-hmm.
something is true, okay, if this will go inside if these lines here, this could be any number of lines here. Okay.
Mm-hmm.
These all will run only and only if the something is true. The value of something is true.
Mm-hmm.
Okay. If it is false, it will say, okay, I cannot run these lines. Where should I go? It will check here. In elif, basically elif is the smaller form of else if. So
Mm-hmm.
so what happens is if it will first check this is true or not. Okay. Let's say
So
this is
after if
false.
always elif should come on.
Not necessarily. If nothing is there also it's okay. It's like this also it's okay. Okay. Like this it is there is also okay. Like this it is there is also okay. Or like this it is there is also okay. Any combination of this is okay. But without this you cannot have like this. Only else cannot be there. Only elif cannot be there.
Mm-hmm. So
Okay.
first
You should
if.
have if should be there for sure if you want to do conditionals. Otherwise,
Mm-hmm.
so for example, you have three choices of doing things. Okay. Then you will write elif, or if you have more than two choices of doing things, then you will have elif added. Otherwise, you'll have only one thing. Okay, so basically, it is like if you have one choice of doing things, I mean, your decision is only once. What do I mean by that? Okay. Um, Let me take a case of, let us think of some case, good case that we can talk about. Mm, Okay. Okay, let's take your office, your house. Okay. You can go to highway and then come home. Or, okay, you can take a train and come home. Okay, you can take a bus. You can take a car.
Mhm.
Okay. Or you can walk. Okay. Train, let's say the cost is 20 rupees. Bus, the cost, let's say, is 30 rupees. Car, let's say it is 50, and walk is, let's say, 10. Okay.
Mhm.
So, how will you choose which of these to do? Okay. Let's say you have some money with you.
Mhm.
Okay. And, okay. I mean, logically, you prefer to do this, then, I mean, this is not something you are coding it inside, okay? But this is something for your understanding. You prefer to do this. If this is not possible, then you will try to do this. If this is not possible, then you'll try to do this. If this is also not possible, then only you will try to do this.
Mhm.
Okay. So what you'll say is, if my money is greater than or equal to 50 rupees, go by car. Okay.
Mhm.
Else, go by, let's say, let me write bus for now. Okay. This
Mhm.
is valid code. But what happens is, you'll check if your money is greater than 50. If you have more than 50, you'll go by car. Very good. But if it is not
Mhm.
true, so if it is false, if this is false, that is you have less than 50. Here it says go by
Mhm.
bus. But there is no
Mhm.
guarantee that you will have 30 also with you. Let's say you have
Mhm.
20. Okay, let's take a case where you have 20 rupees with you. Here this is false. So if you try going by bus, you will not be able to do this because you cannot do it. So it will throw an error.
Mhm.
So
Mhm.
because here you have multiple choices and you have to code all those choices here, you don't need to do it like this. You have to use elif. So you'll say elif.
Okay.
Elif money is less than 50 but greater than or equal to 30.
Mhm.
Okay.
Mhm.
Elif again you'll say money is less than 30 but greater than or equal to 20. And here and will come here. Okay.
Mhm.
Money is less than 50 and greater than 30. That means it is between 31 to 50 rupees you have in your hand. So
Yeah, got
then
it.
you will choose bus.
Mhm.
Then you will choose train. Then in last case you will choose walk. If nothing else, then walk.
Else walk.
Yes. So this is the default case. Okay. It's kind of the default. If nothing else works, do this.
Mhm.
Okay. For here, there is actually zero, not one, even 10, zero. You don't need anything to do this. But if there is
Mhm.
a possibility of doing anything else, do that. Okay. So
Okay.
what you will do is your if you see the flow chart of it, first what you will say, um, if possible to go by car, go. Then if it is not possible to go by car, go try check for possible to go by
Bus.
bus. Okay. If not possible bus, okay, then check by train. Okay. When you have such a case of where you have multiple choices, ellipse can be used. Okay.
Okay. Got it
So
now.
I hope you understood what LF is, how to use
Yeah.
it, when to use it. So if there's only
Mhm.
one choice, okay, if there's only train or walk, okay, or let's say bus or walk, there are only one choice. Okay.
Yeah.
Then
If
you'll
or
only
else.
see you have money. That's all.
Mm.
Okay. This is if else. In this case, you'll use if
Yeah.
and else. That's all.
Alright.
You'll not use elif.
Mm-hmm.
Okay.
Yeah.
Let's take another case. Okay, where else is also not there. Okay.
Can
Um.
we shorten the class because I need to go the work now? Because that's why from tomorrow, can we make it more early?
Yeah. Sure. Yeah. Okay.
It's like,
When do you need to go? How much time you have? Five, ten
because I
minutes.
have to be there at 12 actually. It's only.
Okay then. Fine. Okay then. We'll stop it here today.
Yeah.
Um.
Yes, tomorrow, can we make it early so that more early so that we can be more easy?
Yeah. I'll try asking others what they have. If they are okay, then yeah, we should be able to. Yeah. Just before you go, I'll complete this if thing and then you can go.
Yeah. Yeah.
Okay.
Yeah.
So there is a case where you don't need to use else also. Like for example, if
Mm.
you have time, okay,
Okay.
fill feedback form. Okay. So you are okay, you are doing a course, okay, you are doing my course for example. Okay. After my course, you are going to job.
Mm-hmm.
Okay. Your example only I'll take.
Mm-hmm.
Very good. So
Mm-hmm.
if you have time, do this. If you don't have time, after this, directly go here. That's all. You don't even need to do else here
Mm-hmm.
because default is after course you will go to job. Only if you have time, you are doing this additionally. In this
Mm-hmm.
case, else is also not required. So else and elif are always optional.
Okay.
Okay. You can add them to make your choices more. You can have more choices, or you can remove them and you can make it much more bland or as you need it. So elif and else are optional. Need not be there if you write an if, but if you write elif or else, if should always be there.
Mm-hmm.
Okay.
Okay.
So we'll continue tomorrow after this. Okay.
Mm-hmm.
I'll
Okay.
stop the recording.